Okay, now I have a train coming by, so give me one more second.
Like it's going through your office.
It is going through my office. It's about 50 yards from the window.
Wow.
Yeah, that's why office rent is cheap.
How many a day do you get?
We were, for a while, we were getting 4, but now we're about down to 2. There's one about 10:30 in the morning and one usually about 3:30. This guy's a half an hour early for whatever reason. Friday, yeah, he's trying to get to happy hour. Yeah.
Right.
All right, can you guys hear me okay?
Yeah.
Okay, cool. All right, so before we got cut off, I was about to introduce message-driven beans. So message-driven beans, as a reminder, they're the reusable workflow logic component, so to speak. They are really message handlers, the endpoint of a messaging system. They are invoked as a result of a message being placed on a messaging queue or a messaging topic. Functionally, they are just standard Java objects. Again, we're going to annotate them with the appropriate annotation. The primary difference between a session bean and a message-driven bean, remember, is that session beans represent some extension of a client. Message-driven beans, I can't access them other than through a message. The state transitions of a message-driven bean are going to look very similar to that of a session bean. From an implementation perspective, we haven't quite talked about it yet, but when I actually go to do the message handling in my message-driven bean, I'm going to create a method called onMessage. Think of that as just a business method. Prior to that business method being invoked, the message-driven bean has to go through the standard lifecycle. An object has to be created. It's got to be initialized through that post-construct mechanism, and now onMessage can be invoked. And then at some point in time, similar to the stateless or singleton session bean, at some point in time, the container is going to remove the bean instance from memory, and again, it's going to go through that pre-destroy mechanism. So very similar life cycle to what we just saw. The other primary difference to remember in the context of message-driven beans is that they do support asynchronous, or another way to say that, concurrent interactions. So whenever I go to design and develop a message-driven bean, I do need to be cognizant of the fact that there could be multiple threads interacting with that MDB at the same exact time. That, again, does not exist in the stateful world, nor does it exist in the stateless world. So I have to potentially change the structure of how I design my bean. When I go to develop an MDB, there are a few different steps that I need to go through from a server configuration perspective. Remember that since an MDB is tied to a messaging system like JMS, I need to generally configure the JMS queue or the JMS topic and the JMS connection factory on the server before I deploy an MDB. Otherwise, what's going to happen is that when I deploy the MDB, if those messaging resources aren't initialized, the MDB itself cannot be initialized, and the application will, quote-unquote, gracefully fail the initialization of that EJB. So I want to make sure those resources are set up. Once I've got the resources set up, then I can go ahead and move forward with the development of my MDB. Very similar structure as before. I'm going to develop a class. Notice this time around I don't have to develop an interface. That's because the interface for message-driven beans is already provided for me as part of the EJB framework. So really I just need to implement a class. Once I've implemented the class, I need to configure the class Again, I have two different options there. I can use the annotation-based structure that we've been looking at so far, or I could use the XML deployment descriptor functionality that generally I'm going to use the annotation mechanisms, just easier. After I've configured the MDB, the next thing I need to focus on is how do I deal with the message when it comes into the MDB. There's a method there called onMessage that I'm going to implement. And from a message processing perspective, I might want to do some message filtering. I might want to generate a new message after I've handled the message. I might want to write something in a database, so on and so forth. And then after that, the same steps as with other EJBs. I'm going to compile, package them into an EJB jar, and deploy them into the server. When I go to physically implement the EJB that represents the message-driven bean, there are two different structures. One structure is that I kind of blend the EJB2 model with the EJB3 model, where I use annotations and a compile time dependency on an interface. That's the inheritance-based structure. The second way is I do purely a EJB 3.0 implementation, where I use strictly only annotations to describe the structure of my class. Now, to be honest, there's not a huge advantage or disadvantage one way or the other, but let's look at the two code examples and then we'll cut to a break. First code example, I go ahead and I create my message-driven bean. In this example, notice I create a compile time dependency on the message listener interface. That means I'm going to get a compile time check to ensure that my onMessage method does match that of the method declared in the interface. Those two things, implementing the interface and providing an implementation for the onMessage method, are not enough to make this a valid message-driven bean. I still have to add the annotation. So there's the inheritance-based example. Again, it's blending EJB2 and EJB3. The other option is to do purely annotation-based, and in this annotation-based example, you'll notice there's a slight typo. It should say message-driven instead of message-drive. But you'll notice that I specified the listener interface as an attribute of the annotation. And then I need to make sure that I actually provide the appropriate implementation for that interface. In this case, it's onMessage. The thought process behind the purely annotation-based example is that, again, I don't have a dependency on, this class doesn't have a dependency on the EJB framework, nor does it have a dependency on the JMS message listener interface. So I can treat it as a POJO in some other scenario and move on with life. Questions on either one of those two options?
That's cool. So if I wanted to have my MDB extend some other interface, I could?
Yep, exactly.
That's cool.
Yep. Other questions, thoughts, observations? Okay, so the thing I want you to recognize right now is that both of these examples are valid message-driven beans. I could deploy them in my container, but they are never going to receive a message. And the reason they're never going to receive a message is because they are not associated with a JMS queue or a JMS topic. So I have a valid MDB, but I don't have a valid message endpoint, so to speak. So the next thing that we generally look at is configuring the MDB as a endpoint. It's a pretty simple process. All that I really need to do is I need to specify potentially a couple of different variations, but all I really need to do is specify which topic or which queue the message-driven bean is associated with. In EJB3, the easiest way is to use the first example here, where I specify the mapped name That simply is enough to tell the container that the message-driven bean now functions as an endpoint to the hello MDB queue. The other way, which is a little bit more complete, is that I can specify the JMS properties instead of just the JNDI values. And the JMS properties are always defined in terms of two things, the destination and the destination type. And so here's an example where I've got the physical destination, which is, again, my JNDI value, and then I specify the type of the destination, which is the queue. The advantage of the second scenario over the first scenario is that if the physical destination JMS hello MDB queue was actually a topic instead of a queue, the MDB would not be associated as a message endpoint. So that's the advantage, but it's also the disadvantage, right? Because if somebody misconfigured it, the first scenario doesn't matter if it's a queue or a topic, the MDB is always going to be mapped to that endpoint. So I have more or less control depending on what I'm trying to do. So here's a real basic example in code, mapping this calculator tape bean to the calculator tape queue. Again, I'm assuming it's a queue purely just based on naming convention. Could be a topic, I don't know, but based on naming convention, it is a queue. Second alternate, again, shows me that I am now configuring this message-driven bean. Again, we're more explicit defining what the queue is and the location of the queue. So now if I were to take the message-driven bean with this configuration information and deploy it into my application server, assuming those endpoints are actually set up in the application server, the MDB will function as a pure message listener. It can receive and consume messages automatically. Questions on that? Okay. So in the for the sake of letting you get your cake and ice cream and ginormous trophy, let's pause right here and let me stop the recording. When you come back.
Thank you. Please stand by.